We'll be using spherical coordinates a lot in this course. So in this example, we're going to do a bit of practice converting between spherical coordinates and Cartesian coordinates. So consider the point P with spherical coordinates r theta phi equal to 4, pi over 6, and 3 pi over 4. Let's find the Cartesian coordinates of this point. Before we begin, let's quickly remind ourselves of how Cartesian coordinates are defined in terms of spherical coordinates. So let's draw our x, y, and z axes. If we'd like to label the position of some point using spherical coordinates, we can do this with a radial distance and two angles. So let's imagine that we have a point right here. Let's call that point P. The way we can specify the location of that point is to give the radial distance between the origin and that point. That's what we call r. The angle between the x-axis and the projection of the point down onto the xy plane. That's our angle theta. And the angle between the positive z-axis and the line connecting the origins of the point. I call that phi. It's important to keep in mind that theta and phi are reversed in physics relative to what we're using here, which is what's used in math. So doing a little bit of trigonometry, we can see that this length here, the z coordinate, is just going to be r cosine phi, which means that this length here is r sine phi, and that's the same length that's projected down here, r sine phi, and that's the hypotenuse of this triangle that will give us the x-coordinate, so the hypotenuse r sine phi multiplied by the cosine of theta gives me the x-coordinate, and the hypotenuse r sine phi multiplied by the sine of theta gives me the y-coordinate. Oh, sorry, that should be a theta right there. So this is where we get the equations. X is equal to r cosine theta sine phi. Y is equal to r sine theta sine phi. And z is equal to r cosine phi. And that's what we'll use in this question to convert from spherical coordinates that are given, r, theta, and phi values, to Cartesian coordinates, x, y, and z. So all we really need to do then is work out each of these trig ratios, cosine of theta, sine of theta, sine of phi, and cosine of phi. And then we'll be able to work out x, y, and z. So let's copy this to bring with us down here. And we might as well bring these two. Alright, so let's find the x, y, and z coordinates of this point. So first, I'm going to work out cosine of theta, which is cosine of pi over 6. And if I use my special triangle, pi over 6, pi over 3, 1, 2, root 3. You can see cosine of pi over 6 is just root 3 over 2. Sine of theta here is sine of pi over 6, and that's 1/2. For phi, I've got cosine of phi is cosine of 3 pi over 4. That's got base angle pi over 4. So this is my other special triangle where I've got 1, 1, and root 2. So this is going to be plus or minus 1 over root 2. And remember, you can use the cast rule to figure out if it's plus or minus, or we can look at the graph of cosine. And in this case, since we're in the second quadrant, this is going to be negative. On the other hand, sine will be positive 1 over root 2. All right, so now we can work out our x, y, and z values. X is just going to be the radius times, remember I'm looking up here now, the cosine of theta is root 3 over 2 times the sine of phi, 1 over root 2. And that's equal to root 6. And y is equal to the radius times 1/2 times 1 over root 2, which is root 2. And z, I can do that over here, that's 4 times negative 1 over root 2, or negative 2 root 2. It's always a good idea at this point to make sure that the values that we're getting here make sense. So let's try and sketch where this point is, at least to see that we're in the right quadrant. So again, I'll bring this with me, and I'm going to try and locate this point in three-dimensional space. So we'll worry about the radius later. Let's start off with the angle theta is equal to pi over 6. So that gives us an angle here of pi over 6. Next, let's look at the angle phi. Phi is measured relative to the positive z-axis, so that means we're going this way through that line I just drew and down until I'm making an angle of 45 degrees with the negative z-axis. Like this. And remember, this is right below that line I just drew, so that's a 90-degree angle there. And so combining those two things, I just have to go along this line a distance of 4, and I'll be at my point. To check our values for x, y, and z that we worked out above, we first note that our point is sitting below this quarter of the plane, where x and y are greater than 0, and because it's below there, z is less than 0. Going back to our values, we've got x is positive, y is positive, and z is negative. So that looks good. So let's stop there and say we've got our x, y, and z values, our root 6, root 2, and minus 2 root 2. Those are the Cartesian coordinates of the point P. All right, that's it. Thanks a lot.